So here we go. Let's talk about this. So yesterday, the one kind of problem that we didn't get to. So we did one where we gave you like the sequence, and we said find the rule, then find this term based off of your rule. And then we gave you a specific term in the rule, or a specific term in the sequence, and the common difference. And we said find the rule, find this specific term. Okay? The other style of problem is this one, where I give you two terms in the sequence. Okay? Now I remind you from yesterday that the rule of an arithmetic sequence is the first term plus the common difference times the term number minus 1. Okay, that's the rule. Okay, minus 1. So if I'm going to do that, then I am going to have to use that on this term. So then that would be 21 is equal to, I don't know my first term, I don't know my common difference, but I know that 21 is the 8th term in it. 8 minus 1 is 7, so this tells me that 21 is equal to a sub 1 plus 7d. And that's all I can do with that one for now. Then I'm going to go over here to this other term that was given to me, and I'm going to repeat that process. Now it's 97 is equal to the first term plus the common difference times, now 97 is the 27th term minus 1. So that gives me 97 is equal to a sub 1 plus 26d. Now between my blue and my green equations, I have two equations with two things that I don't know. So that's a graphing, substitution, elimination, matrices type of solution. I would strongly recommend that you use elimination because each of them already has a sub 1 in them, and just a sub 1. So I would go green, and then I would go negative 1 times blue. That gives me 76 here equals 19d. If 76 equals 19d, then what is d equal to? $76 equals 19d. What is d equal to? What? 4. How'd you get that? Divide both sides by 19? Yeah. If d is equal to 4, now what do I do? Blue or green? Blue. Why blue? Smaller numbers, right? Yeah, make it easier on yourself. Seven times 4 is times 4 is 28. How do I solve that one for a sub 1? Okay. Now I can go back to my original rule. I know my first term is now -7. I know my common difference is now 4. So my rule is a sub n is 4n minus 11. Did it ask us? Nope, not to find an extra term. Okay. So when you're given 2 terms, you got to set up a system of equations to solve. Okay. Find me the rule and find me the 25th term in that rule. Find me the rule and the 25th term. That's what I got. Yes?
So would you also set for the rule for a sub n? Would you also set
Yep.
same thing set as well? So
I believe. Thank you. It's just easier. I personally think it's easier to just use the other one from what we're going to get to in a couple of minutes. It makes it easier to go into that simplified version. Just so you know. But yeah, we would. Okay. Good. Good. I'm very confident, yeah. All right. So let's talk about series. So a series is the sum of all of the terms in a sequence. So a sequence is just a list of numbers. Okay? A series is the sum of all of those numbers. Okay? So a sequence is, so like if I had this sequence here, a sequence would be 2, 4, 6, 8, so on and so forth. Okay? But a series is the sum of all of those. Okay? So we add up all of the terms. Okay? We can have a finite series, which means it ends. We can have an infinite series, which means it doesn't end. Okay? Just like yesterday. Refreshing your memory back to Algebra 2, we have this thing that says sigma notation, where we use the Greek letter sigma. And we then, oops, this is now different. I think we've got this, I think I've got this figured out now. I think this part I can get rid of. We had a small issue on the homework, but I think I got it figured out now. Okay? So we have the Greek letter sigma, which which is that fancy big old E. Okay? And it is going to have, typically it's an N, sometimes it's an I, though. Okay? But so typically it will have your variable down there. Okay? And then it's going to have a starting number. Up top, it's going to have an ending number. Those are the numbers for the term that you are going to put into what is called then the rule, the equation, if you will. Okay. So to find the first term, you're going to plug the bottom number that didn't help. Into the rule. That gets you your first term, A sub 1. To find A sub n, which is your last term, you're going to plug the top number into your rule. To find the total number of terms, you're going to take the top number minus the bottom number and then add 1. Now, why we have to do all of that in sigma notation is because of this next part that I'm going to tell you. And this next part that I'm going to tell you is that the sum of the first n terms in an arithmetic sequence, and sigma means sum. Okay? So it's not only are you looking for the words find the sum of the series. If you see sigma, that's automatically sum. Sigma is going to be n, the total number of terms, divided by 2, times the sum of the first term and the last term. Okay? So you need those three things, and that's how you get them from sigma notation. Okay? So let's write this series using sigma notation. Okay? So in the end, I'm going to need a big sigma. I'm going to need a variable. What variable do you want to use? n. N kind of like the variable that we use all the time, so let's use n. Yep, I like n. So that's going to be our variable that we use, so we can lock that in. Okay? In order for sigma, I need first term, so we could just lock this in as 1. And then I would know that my first term is 25. My last term is going to be 250. Do I put 250 then on top? Oh, okay, because that's not the term number. That's the term value is 250. It's not the 250th term. Okay. Do I know anything else? Do I know my common difference? 25, going up by 25. Okay. So I know that. So let's utilize my rule, because I got to come up with a rule. If I utilize my rule, then this is going to be 25 plus 25. I should use a different color. That's right. And for my rule, so then that's going to be 25 plus 25 n minus 25. So my rule is just going to be 25 times n. Would we agree with that rule? Yes? Okay. So then this over here is going to be 25n. Because that's my rule. Okay? So if that's my rule, then 250 is going to be 25 times n, and I can solve for n then, right? Well, n is how much then? 10 is n. So that means that 250 is the 10th term. Which means then that this is 10 up there. Let's take it one step further. Now that we have it written in sigma notation, let's find the sum right away. How many terms do we have? 10 of them. What was my first term? What was my last term? Ten divided by 2 is 5. 25 plus 250. 275. 5 times 275. 1375. Let's write these in sigma notation. You do the left one, we'll do the right one together. Okay? Write the left one here. Here, I'll put a shade up so you don't get confused. Befuddled. Good whack. There you go. Write that one in sigma notation. I get that. Sigma from n equals 1 to 6, because there's 6 terms. And then my rule is negative 8n plus 24. Agreed? Try this one. Again, got to find my rule. A sub n is 3 plus 7 times n minus 1. I get a rule there of 7n minus 4. Where's my n value going to be? What? Good. Because it goes on forever and ever and ever. Okay. Good times. Good times. So yesterday we gave you this problem. We need to find out how many bricks are in the 15th row, okay? Which we can do now, okay? Because if there's 1 brick in the first row, 2 bricks in the second row, 3 bricks in the third row, and so on and so forth, that would give me a rule then of a sub n is 1 plus 1 times n minus 1, which is just going to be 1 plus n minus 1. So a sub n is just going to be n. So there would be how many bricks in the 15th row? There'd be 15 bricks in the 15th row, right? Okay. Oops. 1. That back. Okay. Yeah. So we can find that one, 15th row. But now, to find the total number of bricks, I thought that was going to be the 15th, but apparently not. Now we've got to add up all those together. Which we could do, right? 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, plus 5 is 15, plus 6 is 21, plus 7 is 28, plus 8 is 34, plus 9 is 43, plus 10 is 53, plus 11 is 64, plus 12 is 76, plus 13 is 89, plus 14 is 103. Okay? I'm off by 2, 105. Plus 15 is 120. Right? We can do that. Okay? It takes us a while though, right? Okay? But so adding that isn't always realistic. So therefore, that's where we would then just use our formula right there. Okay? So then we could say here that this is, we've got 15 total rows. Our first one was 1. Our last one was 15. $16 divided by 2 is 8. 15 times 8 is 120. Okay. So it's a little faster to use the formula than it is to just add them manually. Yeah, let's do it. What's our first term? 3. Okay. Need that. What's our last term? 48. What's our term number? How many whole terms do we have? Unknown?
No, we don't.
We don't know, right? So how are we going to find it? Which equation? A sub n? This one? Okay. So 48 is 3 plus, what's my d? 5. Don't know what n is. Okay. So n is 10.
Mhm.
Okay. And then go over here. You can find the sum of the first 10 terms. And 3, 48. 10 divided by 2 is 5. 3 plus 48 is 51. 5 times 51 is 'nailed it. Try that one. What are the 3 things you need?
Term number? And no, how many terms are there?
How many terms there are? That's n.
The
First term
first
and last term. Okay. How am I going to find those 3?
um,
What?
the last term is on top.
What do you mean? It's so 65 is the last term? No. Okay, so what did I say to find the last term? It's in your notes. I promise. From today. It's not the ending number. Well, it's the ending number, yes, but what do I do with it, though? Oops, here it was. How do I find the 3 things that I need? So I need the first term, so I put them into the rule, okay? And then my total number of terms is? Okay. Right. So what do I need? How do I find a sub 1? What do I plug into the rule? So that's 1. So I'm going to plug 1 into my rule. 3 times 1 is 3, plus 2 is 5. Let me change up that you can see the color better. It pops more. How do I find my last term? Plug the top number into my rule. 3 times 65. 195 plus 2. 197. How do I find my total number of terms? $65 minus 1 plus 1. 65. So the sum of the first 65 terms is going to be 65 divided by 2 times 5 plus 197. Five plus 197. 202. 202 divided by 2. 101. 65 times 101. 10. Try that one. Lay back me up on it. Actually, use the calculator. So this is your homework. It will be due next week, Thursday, I believe. No. Wednesday? Maybe it's Wednesday. Could be Wednesday. Next week, no, I lied. Next week, Thursday. Due next week, Thursday. Day of the one.